Hi, good evening. Here is the model designed for process control of a fluidized bed dry chamber. This model, as it has been described in the project presentation, um, it's simple and easy to use. It's made of conventional components that could be easily um, gotten in the open market. I'll just run you through some of the components on the model. Here I have here, this is the start button, this the off button. Here is a toggle switch that interchanges between the two thermocouples attached to the drying chamber. We have a thermocouple monitoring the inlet air and a thermocouple monitoring the outward exhaust air. Here we have the the relay AC alternating current relays. Here, this relay here is connected to the pressure switch, which controls the pressure switch when the pressure drop in the chamber reaches a fluidization level, whereby the bed is said to be fluidized. This relay switch is connected to the temperature controller that monitors drying temperature. It controls the drying when the chamber attains the what's it called now? Attains the fluidization temperature, and this fluidization temperature has been predetermined in the trial run of the model. Here is an interlock relay that controls the overall operation of the module and then the chamber, the drying in particular. And this interlock relay receives signal from both the pressure switch relay and the thermocouple relay. Once these two relays are energized, it signals this, which then energizes and then shuts down the fourth relay, which is the main relay here that controls the drying procedure. This fifth relay is a spare relay that is included in the module as a spare relay. Here we have the what we call temperature controller, which monitors the drying temperature. With the help of the this toggle switch, this temperature controller can monitor both the inlet air temperature and the exhaust air temperature. So this is the model that is being developed, and its function is to monitor moisture content in the drying chamber, and it could also monitor the pressure drop in the chamber. And when the temperature and pressure drop in the chamber reached a fluidization point, the model would end the drying process. So, to demonstrate how this model works, this drying chamber has also been developed. This is the inlet, this is the exhaust thermocouple temperature measurement, and this is the inlet thermocouple temperature measurement. This is a dryer blower that have been attached so that it can supply inlet air and then inlet hot air. Please be aware that this is developed as a prototype to test the functionality of the model we have designed. To I will switch on the model so that we can see how it works. Now I'll switch on the model. Yeah, the dryer operation has commenced. This is the indicator light which has come on, indicating that the system is on. And here we have the dryer motor in operation. Here we have the temperature controller in operation, and here this monitors the change in temperature. Here the preset temperature for the fluidization set point is 120. These had been predetermined in the previous trial run of the model. So the drying operation is ongoing, and here we can have the reading of the exhaust temperature. You can see how the temperature of the exhaust increases. I'm changing the temperature thermocouple to the inlet one. Here we can have the reading of the inlet temperature. You might realize that the inlet and the exhaust has a little difference. This is because I'm testing at the moment with no material in the chamber, so it's like an empty chamber. But I didn't mean there's a material in it. The material will have absorbed more of the inlet temperature, and then it will make the exhaust temperature significantly lesser.